Friday.
So yeah, my name's Ian Feld. I'm the editor of the network error logging and reporting specs. This is set to be about an hour-long discussion. So I want to start with sort of a survey of all of the open issues in NEL and what's going on with that. And then I think there's probably a couple of meaty issues in there that people are going to want to discuss. But let's get to it. So for anybody just getting up to speed, network error logging is an API that basically tries to help site owners understand why users cannot reach their site. Building on the reporting API, it reports on all kinds of basically network error conditions. So it reports specifically on DNS errors, connectivity errors, whether that's the network path to the server or on the server itself if the TCP connection can't be established. It also reports on application errors, so at the HTTP level, any errors that come back. And the model is basically that you set a header on your site, it sets up what conditions reports are going to be generated and where they'll be sent. And then later, future attempted visits will use that header that's been stored to send error reports. It makes it a little bit different than most other uses of the reporting API because we're reporting in cases where the user is not successfully loading a page. So we've done a bunch of work on it since last year to try to clean up the spec. Working on a bunch of privacy issues. We have partitioned the policy cache to ensure that we don't leak information between origins about reporting policies. We've taken steps to ensure that subdomain reports are always correctly downgraded to the DNS errors, as they were always supposed to be, but there were errors. We're expiring policies now after 48 hours, so they are no longer long-lived, essentially with unlimited lifetimes. And we've removed trailer support, so HTTP trailers were included in this. This is all part of an effort to rebuild NEL on top of Fetch. I'll get to that in a minute. So there are about 27 open issues, I think, up this morning. And they fall into a number of different categories. We've got some basic tasks that I think we can do, and likely aren't super controversial. There are questions about new types of information that we might want to report on. There is requests from various people to have mechanisms to minimize the volume of reports. For large sites, turning network error logging on, we're flooded with a large number of reports, most of which you may not care about. And then, of course, there are privacy issues. This is a spec that is hard to get right with respect to privacy. There are still 5 or 6 outstanding issues there that definitely can get through your input. So as far as tasks go, I put checks beside the ones that I believe we've generally talked about and have decided are probably a good idea to do. We do want to rebase network error logging on top of the Fetch API. Right now, it defines things like requests and response and connection phases that really do properly belong in Fetch. There was an argument made, I think in the earlier days, non-web clients could potentially use this as well that don't base their APIs on Fetch, but I believe that we talked about that and the idea that no, this is the W3C web spec. We should be building for the web. And as such, we should be basing this solidly on the web APIs. And then another request that came in actually just during TPAC that says, hey, we do a bunch of JSON in this. The headers are JSON, the reports are all JSON. It would be really nice to have schema. Okay, so new information types. This is really a number of questions about what is in scope for NEL. As I mentioned, it deals with DNS issues, application protocol issues, connectivity issues. It is essentially reporting mostly on HTTP 1.1 errors. And a large volume of web traffic these days is 2 and 3. We talked about this, I think, back in April in the working group and said, yes, we should support H2, H3 errors. We just need to do the work to actually defining what all of those are and how to report them. The other ones there is, I don't believe that we've talked about them here. So signed exchanges, number 99 is an old issue that says we should, those signed exchanges as a method of sending resources through a different path than the traditional contact the origin server and get the resource, can have different failure modes in terms of certificate verification. And maybe we want to include those. Also in this is the idea that the signed exchange itself could include network error logging response headers. And so if the publisher of the resource, not the distributor, the publisher wanted to set up error logging to know when their certificates were failing, they could embed that into the signed exchange. And that would be used. There's been a request to include sub-resource integrity errors. I don't believe this is in scope. I think that SRI failures are much closer to things like CSV. Well, yes, we should probably report them. I don't think network error logging is the way to do it.
Isn't that true of signed exchanges also?
That is a valid argument.
Signed exchanges is largely moved at this point, isn't it? Or
Just we typically like do the presentation, then discussion, just for recording purposes.
We'll definitely get back to that. So number 4 is extended DNS errors. There are apparently a number of extended errors that can be returned by DNS servers, which are potentially useful in terms of figuring out what the actual misconfiguration is. But there are questions about whether reporting those to someone other than the client that made the DNS request is a potential privacy violation if it returns information about what resolvers they were using. And then certificate fingerprints is a request to include the details about the certificate in the case where we're having TLS failures. There are 2 outstanding issues about minimizing report volume, and I believe we've talked about both of these and have decided they're probably good. We should like said on syntax for it. One is filtering reports, so either reducing the sampling volume or changing the report endpoint for different errors, depending on the path that the user was trying to connect to. And then the second one is a similar request, but do this based on error class, so that perhaps your DNS error reports need to go one place and need to be sampled at a certain rate, and your connection error reports or your HTTP error reports go somewhere else. Again, I believe we talked about both of these back in April and decided that we should probably go forward with it. We just need to get the work done. All right, so the last section here is the privacy issues. There are 5 issues here on this list. The first one is a fairly old one, and I'll go into details about what all these are. But there is certain information that is not relevant about the request, depending on where the failure is. And perhaps we should be clearing out parts of the error log that don't include information that's not relevant to fixing that particular problem. We have a potential issue with the kinds of cookies that are being sent. Cookie headers, along with other request headers, are sent to network error log reports. And there are 2 outstanding issues that came up earlier this year by some researchers of the technical, I think. What else we do? So one is that NEL does report on requests that users aren't making voluntarily. And the second one is that we should limit the information, the URL information specifically, that's exposed in NEL reports. But let's tackle each of these one by one. So clearing report body fields, this is probably a good idea. So there's 3 things, or maybe 2 things in this issue. So this is an example of a DNS error. On the left is what we currently send. You can see that at the bottom is the phase DNS. But we're including things like the URL path and query, request headers, response headers. There are no response headers, but there are potentially request headers. as well as the protocol and the method. They're all HTTP concerns that in this case would clearly be irrelevant because you haven't even gotten to the point of making an HTTP request. So the suggestion here is we should truncate the URL to just the origin and remove the HTTP level fields out of the log for DNS requests. Similarly for connectivity, in this case, this is a TCP connection was aborted. There's no point putting in the path. There's no point putting in the method or any of the headers or the status code. You could never have gotten there and they couldn't have influenced the effect there. There's another part of this which says that, hey, by the way, even for cross-origin requests, maybe we should be sending the path. Maybe we should just be sending the URL. But not for cross-origin requests. This is for cases where your error collector is on a different origin than the one where the user was attempting to contact. In most cases, it is a good idea to have a cross-origin error collector because there are many, many network failures where you simply can't reach that origin. You really want to have an out-of-band method of sending errors. I suspect that we don't want to do this, that in this case, the path itself is quite relevant and it would be a shame to lose that. Given that the Segment themselves has said that they trust this. Let's trust this third party with the error logs. All right, cookies. There are two issues on cookies. Very, very similar. So like I said, we send the cookie header, include that in the error logs. And this means in particular that currently same site cookies can be sent cross-origin to a third-party collector. And maybe we should be clearing those out. Also, HTTP only cookies, which are typically not readable by the site, would be exposed in this way by being included in reports. And I mean, I guess the fundamental question for both of these is, should we be taking it on ourselves to modify that header somehow before including it in reports? We've definitely talked about cookies before and credentials in general, and that it can be very, very useful to have those in the reports. However, maybe we should be removing these things. On the other hand, if we're not actually sending the exact bytes, if we're not showing you the exact string that was used in the request, is that a lot less useful? But we should definitely talk about that. Okay, so issue number 150 is ensuring that NEL doesn't report on requests that users do not make voluntarily. Now, I'll do my best to sort of represent the contents of this, but you can go ahead and read issue 150 on network error logging. The upshot seems to be two things. One is that NEL reports on requests other than the top level document. And I believe that this might be a misreading of the original NEL paper. They put in a quote there that says that one of the principles of that we don't report on requests users make voluntarily. But I believe that the paper itself says something more to the effect on we only report on requests the user agent makes while the user is voluntarily browsing away. Right? In other words, we don't do NEL on things that happen in the background, but we definitely do really need to report on error conditions on the page itself in the foreground. Regardless of origin, if you're including images from a CDN and you can't get to those, we should be reporting those. If you're including third-party scripts, like we should be reporting those. And the second thing is that NEL, they bring up that NEL exposes the presence of DNS-based firewalls. So if somebody puts in a DNS server which deliberately blocks certain domains, that NEL will expose the presence of that block. Which again, I think is pretty fundamental to what NEL does, that this is essentially network damage and should be reported like any other network damage. I'd like to get the group's opinion before closing either of these. And then the last one that we got is by the same group, and allowing limiting information in URLs that are exposed in NEL. And they're suggesting that maybe we should make it configurable when you set up your NEL policy, how much of the URL you want to report in certain situations. You know, you want to report the entire URL with path and query parameters. Is it just important to you to report the path, or maybe just the origin? And that you might, as a site owner, have opinions about your site as to what is sensitive information and what you want being sent out in these reports. And of course, if you do that, then the question comes says, what's the default? I think this is probably a good idea, and especially if we couple this with some of the other things about open requests and being able to send errors for different parts of your site to different places, that maybe you want to exclude certain information depending on where that log is going. And that's basically the end of all the issues. If we want to turn off the recording, I would love to have discussion on any and all of these.
All right, so we have a half-hour slot, and there were a few shorter topics that I thought would not take the full half hour, and so I have combined a few sort of lightning talks instead related to various paint timing issues. So high level, earlier this week, I think we decided to refactor element timing algorithms into paint timing or LCP or some to be determined thing, which I thought was a great result. But there are some longstanding quirks and interop issues with those algorithms. Perhaps this is the time to force resolution. And then number two, we in Chrome team, when working with developers, sort of increasingly are hearing repeated feature requests related to paint timing. And I wanted to share sort of distilled use cases that this is motivated by, and then maybe a few proposals that we're hearing, although the specific proposals are less important than the use cases. So as background to work through the paint timing as we move through, in my mind, these are our paint timing APIs. Obviously, there's paint timing, which exposes first contentful paint, and increasingly only first contentful paint on more and more pages that don't make a distinction between those two. Some browsers don't at all. Element timing, of course, for nodes that are explicitly designated with the element timing attribute. LCP, but also event timing is kind of a de facto paint timing because it does report duration from event timestamp to next paint. And then this new long animation frame API is also, of course, reporting on animation frame timings, which is sometimes to next paint, as we discussed earlier this week. So that's the trifecta, I don't know what you call it, API. So for any single paint or animation frame, as we're calling, these are kind of the time points that we use for various things. So some speaker notes here. So some of the APIs do have this concept of an initiating time or event, like a reference point. Event timing has the most obvious and concrete one. The start time value of event timing is the event timestamp, the physical act the user interacted. Element timings have a load time for the resource, like the response end of resource timing. Element timings also have an implicit time origin sometimes, which is often just 0, but it could be the activation start, could be the BF cache restore time, like the page show event time, could be a softnav entry start time, that sort of thing. So it's sort of not explicitly in the entry, but it is something you need to keep or be aware of, and it's contextual. Long animation frames sometimes have an exposed desired execution start. So the simplest example is like a set timeout. The time the timeout callback runs might not be the time that we scheduled it. So there's a delay from the time it was added to the event loop from when it was actually executed. Some of these APIs also have some concept of processing work. Again, the easiest one, event timing, has this block in the middle that you're occupying the main thread to do some processing. Long animation frames also have this concept of a task that's running. But even element timing, your resource, which has been loaded and its response is done, has to go back to the main thread and has to get processed before it could be painted and presented. And these timings are sometimes useful. And then some of the APIs expose main thread rendering times. Long animation frame now in Chromium does expose render start and render end. On other non-Chromium implementers, the paint timing represents a time on the main thread, the like mark paint timing, a part of update the rendering. And then some APIs on Chromium-based browsers do also expose off-thread presentation times. Now, I listed kind of all the names that all the APIs use. Start time can mean any one of these things in any one of these APIs, depending on context. And then there's a bunch of names used that are often not shared, and there's inconsistencies sometimes between start time and duration and etc. Some of the APIs have end time, some do not. So, that can be confusing if these are all paint timing APIs that have similar concepts, but it is also a source of interop issues. So I guess the question is, could we apply consistent labels to these? Start time and duration comes from, the common performance entries base class. They mean different things to different APIs depending on context, but maybe we can add consistent labels for each of these that are common to all the paint timings. We already do some of this. For example, for LCP, the start time value is really the maximum of whatever is exposed to FCP, whatever is exposed under element timing load time, or if you have it render time. It kind of depends on timing allow origin headers and that sort of thing. So we have like a best available value depending on context, and then a very concrete attribute or like concrete name for specific timings. And so we could just do more of that. So I will go through all the slides and then we'll come back to discussion just to make recording easier. But that's one conversation to be had. I made a joke earlier this week, kind of, about FCP and the concept of contentful. But often elements have actual multiple paint timings. So each paint timing had all those time points, but there is not always just like one paint that matters. Animated images has been in conversation recently. So as you're loading the resource for an animated image, you might have the first frame. You have enough content to render the first frame. That element is now contentful and painted, and we can mark its timing. But you might want to know also the last frame when the resource is fully rendered or whatever it is. So you're actually like exposing multiple paint timings, each of which could have any number of those time points. And we're sometimes mixing and matching timings from different paints in order to have the entry have the data we're looking for. Progressive images might have this as well, where you might have like the time where it was progressed enough and then the time when it was fully loaded. Those are two different paints, each of which would have all of the timings, and we're kind of mix and matching. The topic earlier this week was FCP versus LCP. The same element, which is defined as contentful, might have the first frame where any content was displayed, kind of like a progressive load. And then the largest contentful paint or element timing would expose the fully loaded time. So you're representing the same element, two different APIs, two different paint timings for this reason. It's kind of implicit. Also, on non-Chromium browsers, to the best of my ability in testing both Safari and Firefox, the way FCP algorithm works for images is your first paint will initiate a decode, then there will be a future paint operation when the decode is complete. So you have two paints, the paint that kicks off an asynchronous decode and the paint that commits a completed decode. And the reporting of which paint gets reported is kind of differs across every browser. Safari, for example, I believe reports only the first decode, or sorry, the first paint before decode is started. And this ends up with like FCP timings that represent different things in different browsers. And then this isn't a web platform feature yet, but there's lots of requests to measure asynchronous effects after events. I'll talk about that in a second. So you might have multiple different next points for event time. So there's no real request here or solution. It's just something to keep in mind. It's kind of, we're more often bumping into this problem where it's not always a single paint timing, which is to differentiate from how to represent paint timing. All right, so rapid fire, just a couple of feature requests we hear from developers. So I'll start with the use cases because the use cases are what is important here. So first use case is user interactions that have asynchronous effects. So a user interacts with the page, the browser will dispatch events. Those events get captured, run on the main thread, and then we, through event timing, will measure the next paint. However, like one example, the most common example is you might fire a fetch from within your event handler. It doesn't really do much on its own. It's just fetch.then, and then the continuation is the interesting bit, okay? And right now, event timing measures that whole initial time period, you know, if you have janks or long animation frames or whatever, but we have no way to measure the continuation, the fetch.then. And it's a very common request that developers want to be able to measure how long did things take after that continuation runs. They really want to know the end-to-end time of the most important response, not just the initial response. We could talk more about that, but I will point out that in the web framework space, this is becoming a very common pattern where, like, out of the box, more and more rich applications have asynchronous effects. A developer might just write an event handler, do nothing else, and the framework lazy loads that event handler after the interaction. It sort of captures the interaction, queues it up for later, and then the synthetic event dispatch completely hidden to the developer. And so the browser loses the ability to measure that in the first place. That's the use case. The second one is just kind of dynamic UI updates outside of interactions. So we just don't measure these. JavaScript driven re-renders, you know, progressive loading early in page load. You know, we do have LCP, but there are lots of situations where the page just updates. And so frameworks want to be able to measure their own scheduler performance or rendering performance. So like a big DOM update is applied. How long did it take to be visually complete? Let me summarize. And so those are the two use cases. Here's kind of the types of requests we tend to hear. Request number one is like, just let me get the next paint time. This is an important paint. I've put a bunch on the page, just get me the next paint time. So we have request animation frame API in web platform. This gives you the start of rendering and you can measure that. But we do not have a request post animation frame. You don't know when you're done doing rendering work. I showcased sort of ways you could polyfill it, but they're not great. They kind of overestimate time. One strategy you can use is add element timing attribute to any new elements you're adding. But you kind of can't ask for the next paint or the first contentful paint of those elements. You can only get sort of a fully loaded final visually complete. And there are other quirks about element timing, and it's kind of difficult to manage when you have a lot of this stuff. I threw up some questions here. You know, how would this work? What does the API look like? There's no specific proposal. Would it actually force rendering, like request animation frame? When you ask that, just to time it, you're actually forcing the browser to schedule rendering work, which has negative consequences on battery and a bunch of stuff, and sometimes negative consequences on performance. So is there a way to sort of passively listen to presentation times? Anyway, specifics. And then maybe this should be restricted to cross-origin isolated only. We do expose various paint timings already, but maybe the ability to do so at whim should be limited. The other one is broadly, can we make improvements to element timing? So element timing, folks are often surprised to learn, doesn't work if you apply it on a containing element. So imagine applying it to your article element, and you want to know when everything inside the article has, you know, is visually complete. that doesn't work that way. It doesn't report timings of all children or anything like that. So often it would be much more convenient to developers if it did work that way. Folks often also want to know when their page is visually complete. LCP is kind of a proxy. It's efficient, it's good, but it's not actually the final time when everything is loaded. Sometimes folks want to know, specifically like be able to reset FCP and LCP, but I think we have some of that coming with softnavs and stuff. So I don't know that request is that strong specifically. But there's a lot of open questions, like would this apply to the whole body? Could it apply to arbitrary containing elements? Would you have to do viewport visibility intersections? Otherwise, this would never fire. What happens if content was already rendered, like partially rendered? There's a lot of these issues with element timing today where you're updating the page in place, doing a DOM diff. Element timing won't actually fire on elements that have already painted before. So it's complicated, but again, the specifics of the requests, while useful, I think these are the use cases that I'd love to clarify for folks just to understand the solutions that use cases and search of solutions. That's it for presentation.
Cool. It is in progress. So hey, this is an update on the soft navigation efforts. We talked about this. Yeah, we've been talking about this for a while. Talked about the general concept 2 years ago. Talked about more specifically last year at TPAC and right after TPAC. And nowadays, yeah, I just wanted to give an update on progress. So since the last, effectively in the last year, the work has moved from a personal repo to a WICG repo, which now contains an explainer in a very hand-wavy spec skeleton. The spec relies on task attribution, which is also hand-wavily spec. There are a lot of to-dos there, but I think that I have a model that can be specified in relation to the HTML event loop. We ran an origin trial for a few months. There weren't a lot of active participants, but a few late entrants ran a few interesting comparisons, like SpeedKit, for example, ran a comparison between they effectively ran their Next.js app as an SPA and as an NPA and measured which is faster. And the surprising result was that the NPA version was faster. They didn't really dove into how, but it's extremely anecdotal, but this is exactly the type of comparisons that I'm aiming for and allowing people to evaluate different architectures for their own science implementation. So that was a great confirmation. I fixed a bunch of bugs as well as holes in like heuristic and task attribution that it relies on. And here we are kicking off like a second origin trial. I think it just started in Chrome 117. The use cases, just to remind folks, are to correlate performance entries to the corresponding soft navigation. So enable folks to know if their input delays or event timing issues or layout shifts are related to a specific route in their single page app. And right now, all those things are reported to the original, like the hard navigation URL, which is the landing page. That may or may not be relevant. You could have a certain route that has multiple landing pages through which you can reach, and the problems are in this specific route. And right now, developers cannot really know that unless they are keeping tabs of what's being pushed into history or the navigate event or some other elaborate means of trying to keep tabs of what the user is doing, where this will just tell them this is where you have the problem. And then beyond that, we want to be able to trigger load-related entries, so mostly paint-related entries, paint timings, on those soft navigations. So first paint, FCP, LCP. That's the main goal here. The heuristics, as a reminder, we have user-initiated interaction, really, or this also applies to keyboard events, although that fix in the implement heuristic landed and got reverted because I crashed things and releases had to be shipped. But it is basically a user-initiated interaction that results in a URL modification as well as a DOM modification. Those modifications can be async. So we are keeping track of those, like if a fetch did something else that took some time, that then triggered the URL modification and a DOM modification, that is being tracked and all like taken into account. When those things are detected, we fire LCP and effectively restart the size of what it means to be largest. So yeah, when a stop navigation is detected, we restart like from 0, and then for future paints, they re-trigger LCP entries in bumping up in size as they go. The origin trial initially also exposed first paint and FCP, and there were some issues with that in terms of history leaks that resulted in pulling that from, don't give me a face. That resulted in pulling that from the OT. Effectively, we have the visited attribute that is a huge pothole in the middle of the platform for the last 15 years more. And we have a bunch of rules around which CSS selectors and which like CSS rules can be applied to visited links, and we pretend that it's fine for the longest while. But yeah, that is effectively not fine. That's a weird delay. Yeah, so effectively, there was a leak related to visited that was possible with first paint and MCP exposed. There is ongoing work to partition the visited link as the last cache in the platform that is cross-origin for some reason, and to get rid of this cross-origin state. I am super excited about this happening, and this will potentially enable us to re-enable FT and FCP. At the same time, there are like initial conversations with security folks, both about this and about what Michael just talked about, so exposing arbitrary paint times. They still have concerns in a world where cross-origin resources can be loaded before third-party cookies are deprecated everywhere and in non-cross-origin isolated contexts. So there may be some restrictions related to that in terms of exposing first paint and FTP. That is still early conversations, TBD. And now a few challenges that came up from the implementation and experiment, like essentially playing around with it and seeing how well the heuristic does. So the first challenge is with CSS only soft navigations. If you remember, the heuristic looks at DOM modifications, and that kind of works, kind of works for most cases, but at least for this particular case, this is, as you can see, this very much looks like a soft navigation, but all these transitions are done in CSS only. And yeah, you can stop that. All these transitions are only done in playing things. Yeah. So no DOM modifications. The heuristic doesn't pick on that as soft navigation, and this will fixing this would require some changes to the heuristic. Then there are questions around what is a navigation. So for example, here we can see that on this commerce page, picking different options changes a bunch of things about a bunch of things about the site, the price, different options, different thumbnails on the side. But from a user perspective, is that actually a new navigation or an interaction with the existing one? That is a bit in the eye of the beholder. There are other cases like this one where the different options change the image, and it seems like more people think that this is a new navigation, but still, like, it's somewhat of a somewhat of a subjective call. Yeah, so one option that I've been looking into to solve these issues is to tie in some form of rendering input into the heuristic. We already have some hooks in place for LCP, both in specs as well as in the Chromium implementation. I have a working early prototype for text, for image content that is a bit more okay. There are yeah, we already have these hooks in place. Yeah, for images, it's a bit more complex because the image will not paint in the next paint. The image, we have the DOM modification that modified the image, but then the image actually has to load, and we need to keep tabs of that state probably on the image element, but this is just like, yeah, it doesn't seem impossible. It's just a bit more complex than text. But that is an option that I'm currently looking into. And then there are a bunch of questions, like if we're doing that, what would be a reasonable threshold for, like, how would we use the paint input into account? Would we want for like some percentage of the viewport painted, a certain number of contentful elements, something else, or all of the above? And with that, yeah, that's all I had as far as slides go. And that is my update, and I'm looking forward to hear your questions.